This conference will now be recorded.
Yeah. In the OSPF classes, we can discuss here one point. In the OSPF protocol, you can discuss one point now here. What is that point? Okay. OSPF is okay. OSPF is a OSPF is a link state routing protocol. What does that mean? Anyone can you please tell me? Anyone can you please tell me now here? What does that mean by the link state routing protocol? Anyone can you please tell me? Can you discuss this point here? What does the link state routing protocol mean? Can you discuss here? Anyone discuss here? Okay. Anyone know about this? What does that mean by the link state routing protocol? Anyone know that?
It works on bandwidth speed, sir.
Yeah. Okay, that's good. Okay, one more point. That's it. Is there any point? Is there any point? Is there still?
I mean, it copies the database of every other router.
Okay. Okay, that's good. Okay. Next. Okay. I didn't get in the expecting answer. Okay. Helps to get the shortest path from the routing. Okay, that's good. Okay. All the protocols will do like this only. Okay. EtherP also will do the same thing, and RFP also will do the same thing. Okay. Okay. Now, actually, what is the difference? What does the mean by the link state routing protocol here? Actual point here. Actual, okay. What does that mean by the link state routing protocol here now? Suppose now there is a 5 devices. Assume there is a 5 devices. 5 devices. R1 router, R2 router, R3 router, R4 router, and R5 router. We have a 5 devices here. We have a 5 devices now here. 5 devices now here. Now check this here. What is happening up here? These 5 devices, assume it is a R1 router, R2 router, R3 router, R4 router, and R5 router. Okay, these 5 devices connected like this, connected like this, connected like this. Now, in this R1 router, in this 5 devices, I can configure the OSPF protocol here now. I can configure the OSPF. I can configure the OSPF here. I can configure the OSPF here as well. I can configure the OSPF here as well. In this 5 devices, I can configure the OSPF, and I can configure in this R1 router. In this R1 router, I can configure the OSPF area 0. In the R2 also can configure the OSPF area 0. In the R3 also can configure the OSPF area 0. In the R4 also can configure the OSPF area 0. In the R5 also can configure the OSPF area 0. As you here, in this 5 devices, I can configure the OSPF protocol area 0. Area 0. Now tell me, this 5 devices belongs to the single area now? This 5 devices belongs to the single area. Single area. So now, if this 5 devices belongs to the single area, then what has happened, sir? What has happened now? Now check this now here. Suppose assume here now, in this R1 router, suppose there is a few networks here. There is a few networks here. Suppose there is a 10 networks here. Assume here now in this R1 router now there is a 10 networks. 10 networks in this R1 router. Assume now in this R2 also now here we have a 10 networks. We have a 10 networks. Assume in this R4 also we have a 10 networks. Assume in this R5 also now we have a 10 networks. 10 networks like this. Assume like this, assume like this, assume like this. Now, if this 5 devices belongs to a single area, then what has happened here? R1 router will share this 10 networks to R2 router. R1 now, this R1 router will share here now their own 10 networks to R2 router. The R1 router will share their 10 networks to R3 as well. R3 as well. Now R1 router will share their 10 networks to R4 as well. R4 as well. Now R1 router will share this 10 networks to R5 as well here. R5 as well here. R5 as well. That means here R1 router will share their own networks to R2 router, R3 router, R4 router as well as R5 router. Why? Because these four devices belongs to the area 0 only. R1 belongs to the area 0 and these four devices belongs to the area 0 as well. So R1 router will share their own networks to the R2 router as well as R3 and R4 and R5 as well. R5 as well here is. R1 now will share like this to the remaining all the devices belongs to the within an area. R1 router will share their own networks to the all the routers belongs to within an area. Belongs to within an area. R1 will do that. R1 will do that. Sir, what about the R2 sir here? What about the R2 sir here now? R2 also will do the same thing. R2 also will share their networks to R1 router, R3 router, as well as R4 router, as well as R5 router, as well as R5 router. R2 also will share now their own networks to R1 router, as well as R3 router, as well as R4 router, and as well as R5 router, R5 router here. Now R2 also will do the same thing. R2 also will do the same thing. R2 also will do the same thing. Sir, what about the R4 sir here? What about the R4 here now? R4 also will share now here their own 10 networks to R5 as well, R3 as well, R2 as well, and R1 as well. R1 as well. Why? Because R4 belongs to the area 0 and these four devices also belongs to the area 0 only. Area 0 only. So R4 router will share their 10 networks information to the remaining four devices. Remaining 4 devices. Why? Because these 4 devices belongs to the same area, or you can say within an area. Same area. These 4 devices belongs to the same area, area 0. So that's why R4 router will share their own networks to the remaining 4 devices. Remaining 4 routers. Sir, what about the R5 sir here now? R5 also will do the same thing. R5 also will do the same thing here. R5 also will share their networks to R4 router, then R3, then R2, then R1 now like this. R5 also will share now their own networks to the R4 router as well as R3 as well as R2 as well as R1. Okay, now that means here these 5 devices will exchange here now their complete networks information with each other. Okay, if these 5 devices belongs to the within an area, these 5 devices will exchange here now, okay, all the networks with each other. Okay, R1 now will share the networks to R2, R3, R4 and R5 router. R2 also will do the same thing. R2 will share the networks to R1 router, R3 router, R4 router as well as R5 router. R4 also will share the networks to R5 router, R3 router, R2 router and R1 router. R5 also will share the networks to the R4 router, R3 router, R2 router as well as R1 router. Now these 5 devices will exchange the networks information with each other completely. Now here. Sir, if this 5 devices will do like this now here, what is the problem sir here? Why we can configure the multiple areas? What is the problem here? Now check this. Check this now here. R1 router will share their 10 networks to R2 router. Now R1 router will share the 10 networks to R3 as well. So R3 also receives here now 10 networks from the R1 router. R4 also receives the 10 networks from the R1 router. R5 also receives the 10 networks from the R1 router. Sir, what about the R2 sir here now? R2 also will share the networks to R1 as well. 10 networks from R2 router, 10 networks from R2 router, 10 networks from R2 router, 10 networks from R2 as well. Okay. What about the R4 sir here? R4 also will share the networks to the R1 as well. 10 from the R4 router, 10 from the R4 router, 10 from the R4 router, and 10 from the R4 as well now. What about the R5 sir here? R5 also will share now. R5 also will share here their own networks too. R4 as well now. 10 from the R5, 10 from the R5, 10 from the R5 router, and 10 from the R5 as well here. 10 from the R5 as well now. Okay. Let's give me 1 second. Give me 1 second. This now here. So like this 5 devices will exchange the networks information like this. Will exchange the networks information like this. Now suppose here, now check this now here. Okay. In the R4 device now here, a total how many networks we have total here? Total, how many networks can we have now in this R4 router? Can you please tell me all of you? All of you tell me in the R4 router, how many networks now we have? How many networks can we have now in the R4 router? Total networks. Total there is a in the R4 router there is a total guys here of 40 networks are available. 40 networks is there here now. 40 networks is there. Okay. But check this. This R4 router, assume here now, assume here, R4 router, okay. Okay, R4 is a old model device. R4 is a old model device, old router. So R4 cannot store this number of networks. R4 cannot store now this number of networks. Then what we can do, guys? What we can do? What we can do now in this scenario? Tell me now. R4 is an old device now. So R4 memory capacity is not good. R4 memory capacity is not good. So R4 router is not able to store the 40 networks. Assume like this. Okay. Assume like this. Okay. R4 cannot store the 40 networks in their routing table now here. Then what we can do here? What we can do, guys? Tell me now, anyone. What we can do here? Okay. We have to replace with the new router. We have to purchase the new router. Okay. In the R4 place now here, let's replace the new one. Let's replace the new one as per our requirement. As per our requirement, let's purchase the new device. Okay, sir. Here now we can purchase the we can purchase the new device here now. We can purchase the new device. We can put the router in our company. Okay. Then what is that? Okay, new router will able to install this 40 networks. Now everything is working fine. Okay, there is no issues. But there is, guys, here now we are wasting the two things. Here now. One is now here. If you purchase the new device, okay, one new router, okay, then we are wasting two things. Here. One is company expenses. One is company expenses. One is we are wasting the old device. If you purchase a new device now here, okay, new router, we are wasting the two things now here. One is company expenses. One is old device, guys. Okay. If you want to purchase a new router here now, okay, maybe we have to spend some money for this router now here. We have to spend some money for this router. Of course, we have to spend some money from this for this router now here. We have to spend some money for this router. That is there. We are wasting here now our company expenses. If you purchase the new device, then we are wasting our old device here. As well. Sir, then how can we reduce these two things? How can we reduce these two things? How can we reduce these two things here? Okay, do one thing now in this scenario. To reduce these two things here now, what we can do? Let's try to understand here now. Let's try to understand here now. So what I can do this time? Okay, in this R4 router, let's remove the area 0. In the R5 router, let's remove the area 0. Then what we can do now here? I can put now here. You can check this here now. What I can do this time? Okay. In this interface, I can configure the area 0. Okay. In this interface, I can configure the area 0 as well. In this interface, I can configure the area 0. In this interface, I can configure the area 0 as well. Now. But what about sir here? I can configure now here. In this interface, I can configure the another area here. Suppose area 1 here. In this interface, I can configure the area 1 as well. I can configure now here area 1. I can configure now here area 1 as well. I can configure the area 1 as well here. Yes. Sir, if you do like this, sir, here, then what is happening? Here? Let's try to understand here now. All of you try to understand here now. Okay, in this between this R1 and R2 router, I can configure the area ID 0. Between R2 and R3, I can configure the area 0. Between R3 and R4, I can configure the area 1. Between R4 and R5, I can configure the area 1 as well. So then what is happened, sir, here? Then what is happened now here? When we define the way, when we configure the multiple areas like this, then what is happened now? R1 router, okay, will share their network's information to the same area devices only. That means R1 will share the network's information to R2 router, and R3 also belongs to the area 0. In the R3 router, one of the interface belongs to the area 0 only. So R1 router will share the networks to the R3 as well. But R1 router will not share their networks information to the R4 and R4 router this time. It will not share. R1 router cannot share their networks information to the R4 router as well as R5 router. Why, sir? Why? Because R1 belongs to the area 0, but R4 and R5 belongs to the area 1 here now, different area. So this by default, this R1 router will not share this networks information to the R4 and R5 router. It will not share. It won't share to the area 1 router. Area 1 routers, no, it won't share. Okay. Now, what about the R2 sir here? R2 also will do the same thing. R2 also will share the networks to the R1 router. Why? Because R1 belongs to the same area. R2 and R1 belongs to the same area, and R2 and R3 also belongs to the same area. So R2 will share the networks to the R3 as well. But R3 router cannot share the networks to the R4 and R5 now this time. No, it is not possible. It is not at all possible here. No. Okay. But what about the R4 and R5 sir here? What about the R4 and R5 sir here? What about the R4 and R5 sir here? Now. Okay. Now R4 also will share now here their 10 networks information to the R3 router. Why? Because R3 and R4 belongs to the area 1 here. So R4 will share the networks to the R3 router. Now R4 will share the networks to the R5 as well this time. Yes. And R5 also will share now their networks to the R4 router as well as the R3 router. R4 router will share the networks to the R4 router as well as the R3 router. Now here like this now here. This device does okay will exchange the networks information like this. Now check this now here. Check this now here. Check this now here. So R1 router will share the networks to the R2 router as well as the R3 now here. Now R2 also will share the networks to the R1 router as well as R3 router. Okay. Now R4 also will share now here their networks information to the network information to R2 R3 as well as the R5 now here. Now R5 also will share the networks to the R4 now here. And R3 also receives here now at 10 networks from the R5 as well now here. Like this. Now tell me now here, this time, in the R4 router, how many networks can we have now? How many networks can we have now in this R4 router now this time? This time, in this R4 router, how many networks can we have now this time? 20 only. 20 networks only. Now tell me, this device can able to store these networks here, 20 networks. Okay, assume here now this router capacity, this R4 capacity is a 30 networks only, guys. R4 capacity is a 30 networks only. 30 networks only now. Now tell me, R4 can store this 20 networks now this time. Is it possible? Is it possible? Is it possible now? Can you please tell me, all of you? All of you, can you please tell me? Abhinav, Kavita, and Vasant, all of you tell me, is it possible now? It can store or not? Of course, it can store. It can store the 20 networks information in their routing table. But what is the problem here now? But what is the problem here? Can you please tell me what is okay? Anyone can you please tell me what is the problem here? You can see one problem here now. What is that problem? What is that problem? What is that problem? The problem here now, if you configure the multiple areas now here, what is the problem here now? Okay, check this now here. In the R4 routing table now, can we have this R1 and R2 networks? Can we have this R1 and R2 networks in this R4 routing table now? In the R4 routing table, can we have the R1 and R2 networks here? No. Now tell me, the R4 can communicate to this R1 and R2 router. Is it possible? Is it possible? In the R4 routing table now, we don't have this networks information. We don't have the R1 and R2 networks information. Now tell me, is it possible R4 can communicate to these two networks? These two routers? It is not possible. What about the R5? R5 can communicate to this R1 and R2 router. Is it possible? It cannot. Okay, it won't communicate. This time here R4 router and R5 router won't communicate to the R1 and R2 router. R1 and R2 router. Now tell me here now, in the R4 and R2 router, this R1 and R2 router can communicate to this R4 and R5 router. Is it possible? Is it possible? No. Why? Because in the R1 and R2 routing table now, we don't have the networks information. So it is not at all possible here. It is not at all possible, guys. Okay. So that's one of here. So that's one of here. That's one of here. Okay. To overcome this here now, to overcome this problem, what is the R3 will do now here? What is the R3 will do now this time? What is the R3 will do now this time? R3 router will share the R1 and R2 networks into the area 1 now. Area 1. That means now here R3 router will share this R1 and R2 networks to the R4 router as well as the R5 router. Okay. To overcome the what we discussed now here, to overcome those problem here. Okay. These two areas. Okay. For communication purpose here between these two areas, R3 router will share the R1 and R2 networks to the area 1 router, that is called R4 router as well as R5 router now. So R3 will share here this 20 networks to the R4 router and R4 router, R4 router. Like the same only, R3 also will share now here this R4 networks as well as R4 networks to the area 1, okay, area 0 now here, area 0. So R1 router receives this 20 networks from the R3 router. R2 also receives here now 20 networks from the R3 as well now here. R3 as well. But sir, what you are saying, sir, here? Again in this R4 I can see the 40 networks here. Again in this R4 I can see the 40 networks here. Okay. But this router can store the 30 networks only now here. This device can store only the 30 networks. Again, this R4 will receive the 40 networks now. 40 networks now. What you are saying here? Okay, check this guys here. Check this now here. Check this now. Check this now here. Please try to understand here now. Try to understand here now. Okay. What we can do here in this scenario? Okay, we can tell to this R3 router. We can tell to this R3 router. We can tell to this R3 router. This R3 is called as a guys here now. Between the two areas now here, it is the border router now. Between the two areas, it is the border router. It is the border router here. So that's why this router is called as a ABR router, guys. That's why it is called as a ABR router here now. That is called as the area border router. Between the two areas now here, this router contains the two areas. Okay, this area is called as a ABR router now here. That is called area border router. Area border router. Yes. Now, what we can tell to this ABR router? Okay, what we can do? Okay, what we can tell to this ABR router? Okay, we can tell to this ABR router in the area 1. Okay, into this area 1. Into this area 1, don't share the 20 networks like this. Don't share the 20 networks like this. In the area 1 now, don't share the 20 networks like this now here. Let's share only the one network in the R4 and R2 in the area 1 of here. Let's share only the one network now. That is called as a default route here. Let's share now here one default route to the area 1 router. That means now here R3 router, instead of this 20 networks, okay, R3 this ABR router will share now here one default route to the R4 router as well as the R4 router. Now, all of you, can you please tell me in the R1 and R2 router, I can see the 20 networks here. I can see the R4 and R5 networks in these two devices. No issues. Now, in the R4 and R5 router now here, I can see one default route. With the help of this default route, R4 and R5 can communicate this R1 and R2 router. Is it possible? Is it possible now? Is it possible now? Okay, of course, yes, guys. Of course, yes. Okay, with the help of the default route, R4 router and R5 router now here can communicate to the R1 router and the R2 router as well. As they can communicate now here this time, yes. They can communicate this. They can communicate now here this time. Now tell me, how many networks are there in this R4 router now this time? How many networks are there in this R4 router now this time? How many networks are there in this R4 router now this time? Can we see only the 21 networks? Now tell me, R4 can install this 21 networks in the routing table. Is it possible? Of course, yes. Of course, yes. It is possible. It is possible now. Now tell me, can we require the new device here? Can we purchase a new device? Is it required now? Is it required now? Is it required now? Is it required to purchase a new device this time? No. Now check this now here. By configuring the multiple areas now in the OS sphere, okay, we are reducing now. We are not wasting our company expenses. One thing, and one more thing I'll share now. We are successfully using the for all device as well. We are not wasting our device here now. We are not wasting the company expenses as well. Check this now. Like this. Suppose, sir, here, if this 5 routers belongs to the same area, sir, within an area, sir, within an area, sir, here now, in the scenario, can you do like this? Can you share the, okay, can you send the default route? Is it possible, sir, here? Okay, guys, here, if this 5 devices belongs to the single area, in that scenario now here, we cannot do like this. We cannot do like this. We cannot propagate the one default route is not, it is not possible in the within an area. Within an area, we cannot propagate the default route. Okay, but multiple areas, but between the multiple areas now here, we can propagate like this, guys. We can propagate now here, like this is the one default route now. Instead of this 20 networks, I can tell to this RT router that is called ABI router. I can tell to this ABI router, don't share this 20 networks to the area 1. Let's share only one default route to the R4 router and R5 router now here. So RT will do the same thing like this. RT will do the same thing now. So with the help of this default route now here, these two devices can communicate to the R1 router as well as R2 router. In the R1 and R2 now, we have the networks of the R4 and R5 router as well. So this two devices also now can communicate with the R4 router as well as the R5 router this time. Okay, this is the concept of the multiple areas. This is the concept of the multiple areas. Okay, now tell me, does anyone have any doubt here? Tell me, is anyone have any doubt here? You can ask me now. You can ask me, does anyone have any doubt now? You can ask me.
Sir, this ABR router is there now,
Yeah.
sir. Whether if
Yeah.
it is having any 5 networks connected to ABR router, if
Yes.
5 are there, whether it will share that 5 network to both area 0 and area 1.
Suppose you can check this now here. Okay. Suppose here now, suppose in this assume here now there is a router here now R1. There is a router here R1 router here. Suppose assume here now. So I think in the last class you can see the practical now. You can see the practical now. What we can do here now? Suppose here I can configure the 12.1.1.1. I can configure the 10.1.1.1. Okay, we have the two networks here now. There is a switch connected now here. There is a switch connected now here. Switch connected now here. Now check this now here. What we can do here? What we can do here now? What we can do here? Okay, in this router we can configure the OSPF protocol now. Router OSPF. Okay, maybe you can give the process here now. Anyone? Process here. Anyone? Anyone here now? Then what we can do here? We can use the network command now. Network command here. Network command. Can you remember this point? Network command. Tell me, can you remember the network command? Network command. Then this network ID. Then wildcard bit suppose like this. Then what we can do here now? We can define the area ID so on. Area ID na. Area ID na. Suppose area 0
Yes,
or
sir.
area 1 or area 2. So I can define the area 0 suppose here. Suppose in this R5 router, suppose in this RT router, suppose we have few networks here. We have the few networks now here. Okay. Whatever the area ID you can define here. Whatever the area ID you can define here now. In those area only, RT will share the networks information. RT will share the networks information so on here. Suppose in this RT now, suppose that there is a 5 networks here. There is a 5 networks so on here, suppose. Okay, what we can do now here, you advertise this 5 networks into the OSPF area 0 zone suppose, area 0 zone suppose. So R3 router now here will share this 5 networks to the area 0 zone by default. It will share here by default. Like this one. Like this one. Getting my point? Getting my point here.
Yes, sir. Yes, sir. Clear, sir. Clear.
Okay. Suppose here now if you advertise here this 5 networks into the area 1 so on suppose. Area 1 suppose so on, area 1 suppose so on. Okay. Now RT will share now this 5 networks to the R4 as well. R5 as well. R4 as well and R5 as well. Now R1 and R2 router of here, okay, this R1 and R2 router this time here now receives the 25 networks here so from the R3 router. Okay, this 10 networks belongs to the which area? This 10 belongs to which area? Area 1. This 10 belongs to the which area, so on? Area 1.
sir.
This 5 belongs to the which area? Area 1. Now tell me in this area 1 total how many networks we have total? Total how many networks we have total in this area 1?
25 now.
25 now here. So R3 now will share here the 25 networks to the R1 router as well as the R2 router as well as the R3 so on here. R2 sorry R2 so on here. Getting the point here? Getting the point here?
Yes, sir. Yeah.
Any doubt now still?
Clear, sir.
Yeah. Now is anyone have any doubt now? You can ask me. Still anyone have any doubt? You can ask me now here. Still anyone have any doubt? You can ask me. Kavita, Abhinav, and the Vasant, any doubts? Still anyone have any doubts? You can ask me now. Okay, it's a normal router, Abhinav. It's a normal only. When you configure the multiple areas now, it will act as a ABR router. When you configure the multiple areas now, it will act like as a ABR router, Abhinav. That's it. It's a normal router only. It's not a different router. It's a normal device only. Normal router only now here. But when you configure the multiple areas in this device now, it will act as a ABR, Abhinav. ABR. That's it. Okay. Now, check this now here. Before discuss this practical here now, before discuss this practical, what we can do here now, we can discuss the one more concept now here, one more concept now here. That is called as a, okay, backbone area. That is called as a backbone area. So all of you please note down here now. All of you please note down here now. Backbone area. Backbone area in OSPF protocol. Backbone area in OSPF protocol. Sir, what is meant by the backbone area? What is meant by the backbone area? Now check this now here. In the OSPF protocol, area 0, okay, is called as area 0 is called as backbone area. Okay, backbone area in OSPF protocol means here area 0 is called as a backbone area. Area 0 is called as a backbone area. Backbone area. Okay, remaining all areas, remaining all areas is called as non-backbone areas. Non-backbone areas, or you can say regular areas, or you can say regular areas. Sir. Please note down this point. Okay, one more point here now. Okay, in a router, suppose at least one interface at least one interface in a router, at least one interface belongs to backbone area, okay. Remaining interfaces belongs to non-backbone areas, in a router. At least one interface belongs to the backbone area. Remaining interfaces belongs to the non-backbone areas. Then okay, that router is that then that router, then that device, or you can say router, will become as a BR router, that is called area border router. Okay, the device will be okay, then that router will become as a ABR router, that is called as a area border router. Area border router. Yes. Just now here. One more point here now. Okay. AB, okay. Between the multiple areas, between multiple areas, okay. Not on this point here now. ABR only will share the networks information, okay, between multiple areas, multiple areas areas. This is all about the backbone area and the API router. It's all about the backbone area and the ABI router. In a router, at least one interface belongs to the backbone area. Remaining interface belongs to the non-backbone area. Then only the router will become as a ABR router now. That is called as the area border router. Okay, ABR only will share the networks information between multiple areas. That means you can check this now here. Okay, if this router, now tell me this router belongs to the, okay, this router will become as ABR or not? This router will become as ABR or not this time? Of course, this device will become as a ABR router. Sir, why? Why, sir, here now? Why? You can check this now here. This interface belongs to the backbone area. This interface belongs to the non-backbone area. Okay, what is the definition here now? In a router, at least one interface belongs to the backbone area. So you can check this now here. In this router, this interface belongs to the area 0 here, that is called as the backbone area. In this router now, this interface belongs to the area 1, that is the non-backbone area. So that's one of this device will become as a guys here now ABR router. Whenever this device will become the ABR router, then only R3 will share this network. R3 now here will share this area 0 networks to the area 1 and area 1 networks to the area 0 as well, guys. When this device will become as a ABR only, then only it will be possible. Now. That will be possible. Sir, suppose that here now one more scenario, sir. Now check this now here. R1 router, R2 router, R3, sir, here now. R3s are here. Of these three devices are connected like this. Connected like this now. I can configure. Suppose in this R1 router, suppose we have a 10 networks. R3 also suppose we have a 10 networks. Now in the R1 I can configure the OSPF. Okay, I can configure this interface into the area 1, suppose area 1. Okay, in the R2 also can configure the OSPF protocol. I can advertise this interface into the OSPF area 1. OSPF area 1 now. Okay, in the R2 router I can advertise this network into the OSPF area 2. Area 2. In the R2 also can configure, the R3 also can configure the OSPF protocol of here. Now I can advertise this interface into the OSPF area 2 as well. Then what is happened up here? Between this R1 and R2 belongs to the same area. R1 and R2 belongs to the same area. So R1 now will share this 10 networks information to the R2 now this time. So R2 receives here now a 10 networks from the R1 router. Okay, successfully, there is no issue. R2 receives the 10 networks from the R1 router. Now R2 and R3 also can configure the area 2. Between these two devices, I can configure the area 2 now. So R3 also will share now this networks information to R2 as well. So R2 also receives here now a 10 networks from the R3 this time. R3 this time we are successfully now here. Successfully now here. Now sir here. Now tell me this time in this R2 router, is there any interface belongs to the area 0 here? In this R2 router, any interface belongs to the area 0? Area 0 now, area 0 right now? Area 0 right now? No. Okay. In this R2 router now, there is no interface belongs to the area 0. So this device will not become as this R2 router now will not become as a ABR router. It won't become as a ABR router. It won't become as a ABR router. If this router will not be a ABR router, if this router will not be the ABR, then R2 router will not share now this networks information to the area 2, and R2 will not share this 10 networks, okay, R3 networks to the R1 router of this time. It will not share. Why? Because it is not the ABR. So ABR only will share the networks information between the multiple areas. If this device will not become as ABR now, then R2 router will not share the networks information to the R1 and the R3 as well. It will not share the networks information between the multiple areas. Multiple areas. Understood the concept here? All of you? All of you understood the concept here? All of you understood the concept here? All of you understood now here? Anyone have any doubt now?
Clear, sir.
Yeah. Now we can discuss now here practically how can we configure the multiple areas and all these things here. We can check through the practical here. We can discuss via practical here. Practical now. Now check this now. We can discuss via practical here. Practical now here. Let's open the packet tracer. Open the packet tracer. Okay. Let's take now here a few devices. Let's take now here few devices. R1 router, R2 router, R3 router, R4 router, and R5 as well now here, and R5 as well now. This is R1 now, R2, R3, R4, and R5. This is the 5 devices. This is the 5 devices. So what I can do this time here now, I can take the 4 switches now here. Switch 1, I can use one network here now. Switch 2, switch 3, and switch 4 here. I can take the 4 switches now here, 4 switches now here like this now here. Then what I can do this time here now, I connect here all these devices now. R1 to R2, R2 to R3, R3 to R4, R4 to R5, R1 to switch, R2 to switch, R3 to switch, and R4 to switch here as well. Okay. Now check this now here. I can change the name here as well. It is a R1 router. R1 router. It is the R2 now here. R2 now here. It is the R3 now this time. R4 now here. This is the R5 now. These are the 5 devices now here. So sir, here now, how can we configure sir multiple areas? How can we configure the multiple areas now here? Multiple areas now here. Check this now here. Okay. So then what we can do first of all here? What we can do first of all here now? Okay. In the R1 out on the gigabit 0x0 I can configure the IP address. I can configure the IP now here. 12.1.1.1/24 here. In the R2 router in the gigabit 0x0 can configure the IP address 12.1.1.2/24. In the R2 router in the gigabit 0x1 I can configure the IP address 23.1.1.2/24. In the R3 router in the gigabit 0x0 can configure the IP address 23.1.1.3/24. In the R3 and the gigabit 0x1 I can configure the IP address. I can configure the IP address 34.1.1.3/24 now. In the R4 and the gigabit 0x0 I can configure the IP address 34.1.1.4/24. In the R4 and the gigabit 0x1 I can configure the IP address 45.1.1.4/24. In the R4 on the gigabit 0x0 I can configure the IP address 45.1.1.5/24. I can configure this in this 5 devices now. I can configure now, okay, this 5 networks in this 5 devices. Check this now like this. Now in the gigabit 0x1 I can configure the IP address. In the gigabit 0x1 I can configure the IP address 10.1.1.1 suppose /24 here now. In the gigabit 0x2 I can configure the IP address 21.1.1/24 now here. In the gigabit 0x2 I can configure the IP address 31.1.1/24 now here. In the R4 and the R4 router in the gigabit I can configure 40 now here. In the R5 in the gigabit 0x1 I can configure the IP address here 50.1.1.1/24 now /24 like this. I can configure like this now in these 5 devices now. Okay, let's configure the IPs now here. Let's configure the IPs now this time. Let's configure the IPs in each and every device now here. Let's go to this R1 router first of all. Say no here. Say no. Enable a configuration terminal here now. Host name as a R1 router. I can change the device name as a R1 router now here. Okay. In the interface gigabit 0x0, I can configure the IP address here 12.1.1.1. Interface gigabit 0x0. Let's configure the IP address 12.1.1.1. 255.255.255.0 is the wildcard subnet mask here. No shutdown. Exit now here. In the interface gigabit 0x1 also now let's configure the IP address. Interface gigabit 0x1 now. Let's configure the IP address 10.1.1.1. Subnet mask. No shutdown. Exit now here. Now let's go to the R2 device now here. Let's go to this R2 router now here. Let's configure the IP now here as well. Click on the CLI. Let's say no here. Enable config T. Configure terminal. Then change the host name here as a R2 router. Okay. In the gigabit 0x0, let's configure the IP address. In the gigabit 0x0, let's configure the IP address 12.1.1.2. IP address 12.1.1.2. Then subnet mask, no shutdown, exit. In the gigabit 0.1, let's configure the IP address. Let's configure the IP address 23.1.1.2. Then subnet mask here 0, no shutdown, exit now here. In the gigabit 0.2 also now let's configure the IP address. Interface gigabit 0.2 now here. Let's configure the IP address now here 20.1.1.1. Subnet mask here, no shutdown, exit now here. Let's go to the R3 guys. Let's go to this R3 now here. Let's go to the R3 now this time. Let's click on the R3 now here. Say no here. Say no here. Enable a config T. Host name as a R3 router. Okay. In the gigabit 0.0, let's configure the IP address. Interface gigabit 0.0. IP address 23.1.1.3. Then subnet mask, no shutdown, exit now here. In the gigabit 0.1 also now let's configure the IP address. Interface gigabit 0.1 now. Let's configure the IP address 34.1.1.3. Then subnet mask, no shutdown, exit now here. Let's go to the R4 now this time. Let's go to the R4 now this time. I click on the CL line. Say no here. Enable config T. Host name as a R4 router. In the gigabit 0.0, let's configure the IP address 34.1.1.4. Then subnet mask here, no shutdown, exit now here. In the gigabit 0.1, now let's configure the IP address 45.1.1.4. Subnet mask here 0, no shutdown, exit now here. Okay. In the interface gigabit 0.2 also now let's configure the IP address. Interface gigabit 0.2 now here. Let's configure the IP address 40.1.1.1. Subnet mask here, no shutdown, exit now here. Now let's go to the final device now here, R5 router now here. Let's configure the IPs in the R5 as well. In the R5 also now let's configure the IP address. Say no, enable 150, host name as a R5 router. Now interface gigabit 0.0 now let's configure the IP address 45.1.1.5. Then subnet mask, no shutdown, exit now. In the gigabit 0.1 now let's configure the IP address as well. Interface gigabit 0.1. Let's configure the IP address 50.1.1.1. Then subnet mask here now. Now no shutdown, exit now. Now check this. In this part devices, I can configure the IP address as we discuss here now. As we discuss now here. In this part devices, I can configure the IP addresses. So then what I can do this time? Here now, I can configure the area 0. Here I can configure the area 1 guys. Check this now here. Okay. Here I can configure the OSPF area 0. Here I can configure the OSPF area 1 now here. OSPF area 1 over area 1. Okay, let's define anyone as per your requirement here. Let's define here now anyone as per your requirement. As per your requirement here now, you can define here anyone, any area here, either area 1, area 2, area 3, area 10, 20, 30, 40, anyone here, as per your requirement. As per your requirement here now. So first of all now here, let's go to the carbon router now. Let's go to the carbon router now here. Let's configure the OSPF now here. Let's configure the OSPF here now. Router, OSPF, then define the process ID here. Then configure the process ID now here. That is up to your requirement. You can define here any value here. From the 1 to 65,535, you can define here any one. That is up to your requirement. That is up to you. Okay, so I can define the okay, process ID is the 100 here now. 100 now here. Then network. Okay, I can advertise this network into the which area now? This network belongs to the which area? Which area now? This network belongs to which area? It's a area 0, area 0. So what I can do this time here now? This 12.1.1.1 guys here. What is the network ID for this 12.1.1.1/24 now? Can you please tell me, all of you? All of you, can you please tell me for this 12.1.1.1/24? What is the network ID? Network ID. Network ID. It's a wildcard bit, so on. It's a wildcard bits. But I'm asking for the network ID, so on. That is subnet mask zone. Subnet. That is a subnet mask zone. Okay. For this 12.1.1.1 IP address, okay, network ID is a 12.1.1.0. This is the 12.1.1.0 will be the network ID of here for this 12.1.1.1 IP. For this 12.1.1 IP of here, this 12.1.1.0 will become the network ID. So network ID. Understood? Okay. Then it will ask you the wildcard bits. Wildcard bits 0.0.0.255 is the wildcard bits. Now this 12.1.1 belongs to which area? Which area here? Which area? It belongs to the area. Area 0. Area 0. Then define here now area 0. Then define here now area 0. Press enter now. Now one more network is there in this. Okay, R1 router network. This 10.1.1 belongs to which area as well? This 10.1.1 okay, network belongs to which area? Area 0 as well only. Area 0 as well only. Press enter here. Exit now. Now let's go to the R2 router. Let's go to the R2 router now here. In the R2 also now let's configure the IP address. Sorry, OSPF protocol here now. Router OSPF 100. Now network. Okay. This 12.1.1.2 belongs to which area now? Can you please tell me? Can you please tell me? This 12.1.1.0 belongs to which area? Which area? Area 0. No, Vasan, there is the area 0, Vasan. Check this now here. Until this interface here now. This interface, this interface, this interface, and this interface here now. This 4 interface belongs to the area 0 only, Vasan. Area 0 only. And in the R3 router, this gigabit 0 by 1. In the R4 now, gigabit 0 by 0, gigabit 0 by 1. In the R5 now, gigabit 0 by 0 belongs to the area 1, Vasan. Area 1. Okay. Up to this R3, up to this, okay, up to this gigabit 0 by 0 now here, all these networks and interface belongs to the area 0 only, was area 0 only. It's not area 1, was okay. It's not area 1, it's a area 0, was understood here.
Okay, sir.
Yeah. Now this 12.1.1 network belongs to which area? Area 0 only. Press enter now here. The network, one more network is there. This 23.1.1. This 23.1.2 belongs to which area? area 0 as well only, area 0 as well only. Now one more network is there here now, that is a 2111. This area, this network also belongs to the area 0 only. Enter now here, exit. You can check this now here. In that way I can advertise this network into the area 0, this network into the area 0 as well now, and this network into the area 0 as well. In R2 router, I can advertise now this network into the area 0, this network into the area 0, this network into the area 0 as well. Now let's go to the R2 this time. Let's go to the R3 this time. Let's try to carefully understand here now. Router OSPF 100 now. Network 23.1.1.0 wildcard bits. Now tell me, this 23.1.1 network belongs to which area here? Can you please tell me, all of you? All of you tell me, this 23.1.1 network belongs to the which area? Area 0 only. Area 0 only. So area 0%. Area 0, area 0. Then simply press here now, enter. Simply press enter now. Now tell me, this 34.1.1 network belongs to the which area? Which area now? Which area? Can you please tell me, all of you? Area 1. Area 1. So what we can do simply here now? Simply what we can do now here? Network 34.1.1.0 wildcard bits. Area 1 of here. Simply press enter, guys. That's it. Okay. There is no difficulty here now to configure the multiple areas. There is no difficulty here now. We just change the area number here now. We just change the area ID here. That's it. We just change the area ID, guys. That's it. That's it now here. That's it. Now let's go to the R4 now here. Let's go to this R4 router now here. Let's go to the R4, guys. Here R4 router now here. Now with R4 also now let's configure the OSPF protocol. Router OSPF 100 now. Network, this 34.114 belongs to the which area now? This 34.1.1.0 belongs to the which area? Can you please tell me, all of you? Area 1 now here. This 45.1.1 network now belongs to which area? Area 1 as well. 0.255. Area 1 as well. Now network here now. Okay. This 40.1.1 belongs to the which area? This also belongs to the area 1 only. Enter. Exit of here. Let's go to the RP of here final device. Let's go to the RP device now here final router now here final router. Router OSPF 100 now. Now network 45.1.1.0 wildcard bits. Area belongs to 1 now here. Now wait here, never will become up here now. Wait now, never will become up now here. The network, okay, this 50.1.1.1 belongs to the area 0 as okay, area 1 as well now. Area 1 as well now here. Of 50.1.1.0 subnet mask wildcard bits here now. Area 1. Exit now here. Exit now here. Okay. Now, okay. Now check this now here. Between these 5 devices, I can configure the multiple areas. Between these 5 devices, I can configure the multiple areas now. Multiple areas successfully. Now check this now. R1 network information, this 10.1.1 network, come to the R2 or R4 or R4 or not. Now check this. Let's check this now here. This 10 network and 20 network come to this R4 or R5 or not. Let's check this now here. These networks, okay, will be in the R4 routing, on the R4 and R4 and the R5 routing table or not. Now check this. Now check this here. Now check this. Let's go to the R5 device now here. Show IP route. You can check this now here. In the R5 router now, can I see the 10.1.1 network now? Can I see this network in this R5 router now? In the R5 router now here, in this R5 router now here, can I see the 10.1.1.0 network now here? In this routing table now, can I check this? Yes. Okay. In the R5 now, I can check this here to 20 dot, okay. 20.1.1.0, can I see this network information? Can I see this network information in this R5 routing table? In the R5 routing table now? Of course, I can check this. Okay. But sir, here now. But sir, here now. What does the OIA means, sir, here now? But what does the OIA means? What does mean by the O, guys, here? What does the mean by the O? What does the mean by the O here? O means OSPF. IA means here now. OSPF inter area. OSPF inter area. IA means here now. OSPF inter area. That means here now. This 10.1.1.0/24 belongs to the different area. Belongs to different area. So R5 this router belongs to the different area. R5 belongs to the different area, and this 10.1.1.0/24 belongs to the different area as well. Different area as well. So that's why I can see as a OIA, guys. OIA. That's why I can see as a OIA, guys. OIA. That's called as a inter area network. Inter area network areas like this. Inter area network like this. Okay, and you can check this now here. This 20.1.1.0 also can check this as a OIA form. OIA. That is called as a this 20.1.1.0/24 also belongs to the different area. R5 belongs to the different area. This network belongs to the different area. So that's why I can see as a OIA, guys. I can see as a OIA. OIA. Now let's go to the R4 as well now here. Let's go to the R5 as well now here. Show IP route here. Show IP route here. You can check this now here. In this R4 also can see now here 10.1.1.0. In the R4 also can see now here 21.1.0 as well now. I can check the 10.1.1.0 as well as the 21.1.0 as well as the 21.1.0. You can check this now. You can check this now here. Let's go to the R1 as well now here. Show IP routes. Can you check this now here? In the R4 routing table, I can see now here 40.1.1.0 now here. And the 50.1.1.0 as well now. You can check this. In the R1 routing table, I can see as a 40.1.1.0 as well. And the 50.1.1.0 as well now here. 0 as well now. Let's go to the R2 as well. Let's go to the R2 as well. You can check here now as well. So IP route. Check this now here. In the R2 also can see now here 40.1.1.0. In the R2 you can see the 50.1.1.0 as well. You can check this. You can check this now here. You can check this. Why? Because now here it is the ABR router. This R3 is the ABR router now. So that's why these two areas, okay, between these two areas now, you can see the networks information with each other. This ABR router will share the area 0 networks into the area 1 now. Okay, area 1. This ABR router will share the area 0 networks into the area 1 and area 1 networks into the area 0 as well. Area 0 as well as here, like this now. This is called as a multiple areas in the OSPF protocol. Multiple areas in the OSPF protocol. OSPF protocol. Anyone have any doubt now here? Anyone have any doubt now here? You can ask.
Sir, here router 3 whether it will participate in DR BDR elections, sir, router 3.
Definitely, okay. Definitely, they will participate in the BDR. They can participate in the DR and the BDR election. Definitely.
Here there is 2 area now. So there is that means there is 2 DR, different DR for different area.
No, not like this. Okay. DR and BDR election will happen for the interface level, not for the router level. It will be happen
Okay, can
for
you
the
just
interface level here, not for the router level.
okay, sorry, is it possible? Can you just explain it in for a few minutes, sir? DR BDR election here in this topology.
Check this now here. Check this now here. Check this here. Check this now here. Okay. Remember one point here. Always here. Always remember one point here now. Suppose you can check this now here. There is a router here now. Suppose there is a router here. Suppose there is a router now. There is a router here now. Suppose here now. This router connected to the multiple devices. Like one more device here now. One more device now here. One more device now here. One more device now here. Okay. One more device now. One more device. Assume it is the R1 router. It is the R2 router. It is the R3 router. It is the R4 router. It is the R5 router. It is the R6 router. Suppose this R1 router connected to the 5 multiple routers here now. 5 multiple routers here now through the different interfaces. Through the different interfaces here. Interfaces now. So assume it is the 0 by 0 interface. It is the 0 by 1 interface. It is the 0 by 2 interface. It is the 0 by 3 interface. It is the 0 by 4 interface. It is the 0 by 4 interface like this. Like this. Then what has happened here? What has happened here now? Between this R1 and R2 router now here. Between this R1 and R2 router now here now. You can see the DR and BDR election here now. Between this interface, between the 0 by 0, between the R2 router now here, you can see the DR and the BDR election now. You can see the DR and the BDR now. Between this, okay, 0 by 1 to between the R3 router now, you can see the DR and the BDR election as well. DR and the BDR as well. DR and the BDR as well now. Between the 0 by 2 to between the R4 now, you can check the DR and BDR election as well now. DR and BDR as well now. You can check this here. I can see the DR and the BDR now here. Between these two devices, okay, between this 0 by 2 interface, between this interface here. Between these two interfaces now here, I can see the DR and the BDR election here again. Between the 0 by 3 to between the R5 interface now, I can see the DR and BDR as well. Okay, there is election will happen for the DR and the BDR purpose. There is election will happen here between the 0 by 3 to R5 at this interface. R5 at this interface. Between the R1 to between the 0 by 4 to between the R6 interface now here. Again you can see the one more okay. Again one more time also again we can see the DR and the BDR election here now. DR and the BDR election here like this. Okay, that means here now this DR and the BDR election will be happen for the interface level here, not on the router level here. So remember this point. Remember this point. Okay, this DR and the BDR level, this DR and the BDR election will be happen for the interface level now here. For each and every interface now we consider DR and the BDR election here. Okay, so for every interface here, suppose this interface belongs to the OSPF protocol here. Definitely now there is a DR and the BDR election so on here. Definitely so on. Definitely. Getting my point? Getting my point?
Yes, sir. Yes, sir. Yes.
Okay. If it is a ABR router, okay, or any router here, anyone here now, anyone here, okay, it may be the any router here now. But if this case, okay, in the interface level now, can definitely see the DR and the BDR election here. So on here, compulsory. Compulsory. It is the okay. It is compulsory. Oh, sorry, it is compulsory. So
Okay,
okay.
sir. Yes, yes.
I will show you now here. You can check this now here. Sir, how can we check this now, sir? Here it is the DR and the BDR, sir. Here, how can we check this? How can we check this gigabit 0 by 0 is the DR and the BDR, sir? Here, how can we check this now? Let's go to this R3 router now. Let's go to this R3 router now this time. Enable. Okay, sorry. Exit. Show IP. OSPF. Interface. Gigabit. Okay. 0 by 0. Gigabit 0 by 0. Gigabit 0 by 0. Then press enter now here. What is the state here now? What is the state here now? What is the state here? It's a BDR. It's a BDR. Am I right? It's a BDR. Now in the R3 only now here, in the R3 only now here, let's check the one more interface here, gigabit 0 by 1 now. Let's check the one more interface that is called as a gigabit 0 by 1 now. Let's check this. Show IP OSPF interface gigabit 0 by 1 now here. What is the state here now? What is the state here now? It's a DR. It's a DR. That means now here DR and the BDR relation can be happen for the interface level here, not on the router level. Not on the router level, it is happened for the interface level here. Interface level here, understand this. Remember this. Remember this. Okay. Any doubt here still?
Sorry,
Any
there is
doubt
one more
still?
command. One command, no? Show IP OSPF neighbor.
Yes, we can see as well here. We can check this as well here now. Show IP OSPF neighbor. Yes, we can check this as well. R2 now will form the neighborship with the 23.1.1.2. That is called R2 router now here. R2 is the DR now. That means here R2 is the DR here now. Okay. In this neighborship, for this neighbor now here, from this neighbor now here, R3 is the BDR now. This device is the DR router now here. This 23.1.1.2 is the DR router. DR router. Okay. In this neighbor now here, for this neighbor now here, R3 will become the BDR. R3 will become the BDR. For this 45.1.1.4 neighbor, R3 will be the DR, and this R4 will become the BDR here. So you can check this as well. You can check this as well.
Sir, why other networks are not showing in the neighbor ID column, sir? There are a few more networks now in this
Why?
topology.
Yes.
For example, 12.1 is there. For
Yes.
some other 33 something is there. No, that ID is not. Why not showing in network ID, sir? Not in the network table here. Only 2 why it is showing, sir.
In this neighbor table. In this
Yes,
neighbor
sir.
table.
Correct. Yes, sir. For example, if
check this now. First of all, check this now here. Now see this now here. R3 will form the neighborship with routers here. R3 will form the neighborship with routers. From which routers? R3 now here will be the neighbor for the which routers?
R2 and R4.
R2 and
R4.
R4 now. So what is the R2? Okay, so in the neighbor table, it can show only the neighbors information only. So R3 will form the neighborship with the R2 router as well as the R4 router. So that's why in the neighbor table, R3 will shown as the R2's information as well as the R4 information only shown here. Only. Why? Because now here R3 will form the neighborship with the R2 and the R4 only now. R2 and the R4 only now here. So that's why it will show it in the neighbor table of these 2 neighbors information. So these 2 neighbors information shown only this time. Can you get my point?
Yes, sir. I got point. But in R2, no, other side there is 12.1 network, no, in the R2 router.
No. See this now here. R3 router cannot form the neighborship with R1 router now. R3 router now here cannot form the direct neighborship with R1 router now. This tell me now here R3 can form the neighborship with the R1 router system directly.
No, that is not possible.
Yeah. So R3 router now here cannot form the direct neighborship with the R1 router now. Cannot form the direct neighborship with this R1 router. So that's why in the neighbor table now here we don't see this network information so on. We don't see this network information so on. Getting my point?
What about that? Yes, sir, I got point. What is that? 12.1.1.2. That is the network is part of that R2, right? 12.1.1.2.
Yes.
That is belongs to router 2. So since
Yes.
R3 is in neighbor with R2, so
Yes.
what I am thinking is that 12.1.1.2 network also should appear in the neighbor table.
No. Check this now here. Check this now here. What is the what is this here? What is this? What you can check this now here? It is a. It's a what is this here?
Neighbor ID.
What is it? It's a neighbor ID. Can you discuss in the previous classes? Can you discuss about the router ID here? Router ID. I think can you discuss this
Yes,
point here?
sir.
Router ID now here. Router
Yes,
ID now
sir.
here. That means now here. Let's go to the R2 router now here. Let's go to the R2 router now here. Show IP protocols. Show IP protocols. What is the R2? Okay, router ID here now. What is the R2 router ID here now? What is the router ID here?
Yes, sir. 23.1.1.2.
So R3 will form the neighborship now here with which okay with which IP address? With which router ID here? With which router ID here now? 23.1.1.2. That means here now R1 R3 router now here. Okay, can form the neighborship now here with the 23.1.1.2 neighbor. Okay, router ID router here now. R3 router will form the neighborship with the 23.1.1.2 router ID router here so on here like this. It is not an IP address here. It is a router ID so on here. It's a router ID so on here. It is not an IP address. Okay, it is not an IP address here. It is a neighbor router ID so on here. Neighbors router ID so on here. Getting the point here?
Oh, yes, sir. Yes, sir.
Okay, it's not IP address here. It's not IP address here. Okay, you can think now here. Okay, I think okay. What's your question here now, sir? In this R3 table now here, I can see the 23.1.1.2 sir here, but why I cannot see the 12.1.1.2? That's your question here. Am I right?
Yes, 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 sir. Yes.
Okay, okay. It is not in this IP address here so on. In this R3 table now, in this R3 neighbor table now, you can see the 23.1.1.2. It is not IP address here so on. It is a router ID so on. It is a router ID so on of this R2 router. R2 router. Getting my point?
Yes, sir. Clear now. Yes, yes.
Yeah. Let's go to the R4 now this time. Let's go to the R4 now this time. Show IP protocols. What is the R4? Okay, neighbor ID. What is the R4? Router ID here. What is the R4 already here now? 45.1.1.4 now. 45.1.1.4 now. Let's come to the R4 here again. What is this? 45.1.1.4. That means here R3 router will form the one more neighborship with the one more router. This router ID is a 45.1.1.4. So this is the information here. Not is it is not IP address. It is not his IP address here. It is the router ID. So it's a router ID. So router ID. Getting the point here.
Yes, sir.
Understand now?
Yes, sir.
Okay.
Clear, sir. Now.
Still any doubt? Still any doubt now?
No, this is
Anyone have
clear.
any doubts?
One more question, sir.
Yeah.
This DR BDR, no, in every router, if you check, you will get different DR BDR, right, sir?
Yes.
So in that case, no, so this what happens now when after forming the DR BDR, every router will send their the information to only to DR, right, sir?
Yes.
not to other DR other routers. So if you check
Yes.
this router 2 here,
Okay.
it is in between router 1 and router 3, right, sir?
Router 1 and
So
router
in
3 is yes.
yes, so in router, if you check between router and router 2, there is one DR,
Okay.
and between router 2 and router 3, there is one more DR, right, sir?
Yes.
So it will send that its information to two DRs or what here?
No, 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 no. Check this here now. Check this here now. Check this now here. What is that here? Between the two devices now here. Okay. Suppose here is assume it is a DR now. It's a BDR now. It's a BDR now here. Now, these two devices, these two interface belong. Okay. In this, between these two devices only now here consider one DR and the BDR now. Between these two R1 and R2 only consider only one DR and the BDR now. Only one DR and the BDR now here. These two devices now here will exchange the network's information with each other. R1 will change their database to the R2 router now here, and R2 will exchange the database to the R1 as well here, so on. R1 as well, so on here. Between this R2 and R3 now here, we can see the one more DR and the BDR here. But it's a different one here. It's a different one here. Okay, this is the one DR and BDR now here. Now here also, now there is a one more DR and the BDR here, so on. There is a one more DR and the BDR, so on here now. In this scenario now, there is no problem here. There is no problem here, so on. R1, okay, R1 now here will share the database to the R2 router now. Then R2 now will share the R1 database to the R3 as well, so on here. Okay, there is no problem here. There is no problem here now. They can exchange the information here. Okay, even if it is the DR and the BDR, they can exchange the information over here compulsory. Compulsory, so on. If suppose here what you saying now here, what you saying now here, sir, DR only now here, DR only, sir, here, BDR only will share the network to the DR, sir, here, DR, sir, here. Okay, well, you are saying like this now, you are saying like this now here. Now also, okay, okay, that BDR will share the network information to the DR router, so DR can communicate to the BDR now here. But what about the BDR can communicate to DR router now this time? Is it possible now? Check this now here. I will give you some example here now. Check this one here now. There is a two devices here now. R1 router, R2 so on. This two are the. This is the DR and the BDR. So in the R1 now there is a network information now here. In the R2 now there is a network information now here. 24 now. So what is your assumption here now? What is your assumption here now? BDR only share the network information to the DR router. Only share network information to the DR router is your assumption. Your assumption here now. So if the R2 router now will share this network information to this R1 router. Now R1 receives here now this network information in their routing table here, in their routing table. So, but now tell me, in the R2 now, can we have this 10.1.1 information now? Can you have this 10.1.1 network information now? No. If this in the R2 routing table now, there is no 10.1 network information. There is no 10.1.1.0 network information. Now R2 can communicate this 10.1.1.0. Is it possible here, Saurabh? So on. Is it possible so on here?
No, sir. Now not possible.
No, not possible here now. That means here now, okay. Even if it is a DR and the BDR now, these two devices will exchange their database table here now. So remember this point. Remember this point here. Okay. Even DR and the BDR now will exchange the database here now with each other, so on, with each other, with each other, so on, with each other. That means now here R1 also will share now the database to the BDR as well, so on, BDR as well, BDR as well now. So R2 resource here now this 10.1.1.0/24 now here via R1 router. Now tell me this two can communicate now here. R2 can communicate to this 10.1.1.0 now. Yes. R1 can communicate to this 21.1.0. Yes, they can communicate now with each other, so on this time. Okay. Okay. That is your assumption. Okay, Sohan here now. It's a wrong Sohan. Okay, DR and BDR now will exchange their database with each other. Sohan. Remember this point. Remember it. Okay. Understood?
Okay, sir. Yes, 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 sir. Yeah.
Now, if you want to check the connectivity now here, you can check this now here. You can check this now here. I will show you one thing now here. Show IP route or show IP OSPF interface gigabit 0/0 now here. It is the DR router now. R1 is the DR router now. R1 is the DR now. R1 is the DR now. Let's go to the R2 now here. R2 is the show IP OSPF interface gigabit 0/0 now here. Okay, R1 is the DR now. R2 is the BDR now. Now check this now here. Now check this. Okay, two routing tables now here. Check the two routing tables now here. Show IP route. And the R2 router now here. Can I see this 10.1.1 network here? Okay, in the BDR router now here. Can I see the DR network information? It is a BDR router. Actually, it is a BDR router now. In the BDR router now, can I see this 10.1.1.0/24 now here? Can I see this network information? Of course, yes. Let's go to the R1 as well now here. You can check this now here. Show IP route. In the R1 also, can I see this 20 network now here? Of course, yes. The pins here, so on. Okay, DR and the BDR also now here will exchange their network information. Will exchange their database information. Understood now here?
Yes, sir.
And they can
Yes, sir.
communicate now with each other. You can check this. R1 can communicate to the 20.1.1.1. Let's go to the R2 as well now. R2 can communicate to the 10.1.1.1 as well. You can check this now. You can check it now. So they can communicate now. Okay.
Yes, sir.
Still any doubt here, anyone? Still anyone have any doubt now? You can ask me.
Yes, sir. Yes, sir.
Tell me so on. Tell me now.
Sir, is it possible to have more than one ABR in one network of 5 to 6 routers? I'm saying, is it possible to have more than one ABR in a one network?
Of course, yes, possible. Yes, possible. You have now. You can configure the n number of ABRs here as well. As per our requirement, you can configure. No issue.
Okay.
Okay. One more point here now. Please note down here, all of you. Please note down here one more point here now. Cisco recommends here now. Cisco recommends here now. Okay. Within a single area, Cisco recommends here now. In one area. Okay. Let's configure the 42 50 devices only now here. Let's configure the 42 of 50 devices only. That means 50 routers only now. Here. Okay, don't configure more than that. That means here now in area 0, let's configure around of 40 to 50 routers. Let's configure the 42 of 50 routers. In the area 1, let's configure the 40 to 50 routers. In the area 2, let's configure the 40 to 50 routers. Okay, as per your requirement. Okay, you can do that. You can configure the n number of ABRs as well. Now there is no issue. There is no issue. Okay, you can do that. As per our requirement here, you can configure the n number of ABRs as well. So, getting my point?
Yes, sir. And one more thing, sir. Hello.
Yeah, tell me.
Sir, one more. The topic was the ASBR, Autonomous System Boundary Router. Is it same as the ABR or is it different?
Okay, it's a different. It's a different one here. It's a different one here. Saurabh, it's a different one here up now. Okay, ASBR means here. Okay, when we perform the redistribution into OSPF protocol here. When we perform the redistribution into the OSPF protocol, okay, so Abhinav here now, then that router will become the ASBR router. Okay, we can discuss this topic in the CCNP level, Abhinav. CCNP level, CCNP level here. CCNP level. Okay, once you go to the CCNP level Abhinav, we can discuss about this. What is the redistribution now, and how can we perform it? What is the ASBR, and we can discuss it everything in the CCNP level, sir. Sir Abhinav. Okay.
Okay,
It's a
sir.
different concept here. It's a different concept. ASBR. Okay. ASBR means here now autonomous system. Autonomous system. Okay. Boundary router. Autonomous system. Boundary router here. ASBR. Okay. Any doubt here? Anyone still? Still anyone have any doubt now?
No, sir. Clear.
What about you, Abhinav and the Vasant? Any doubt now still? Does anyone have any doubt? Can ask me. Okay. Now, guys, here, from this topic, we can complete the OSPF protocol. From this topic, we can complete the OSPF protocol. OSPF protocol completely, guys. As a CCNA level. As a CCNA level. Okay. But if you go for the CCNP level now here, we can discuss the in depth about the OSPF protocol in the CCNP level. In depth about this protocol in the CCNP level now. CCNP level. Okay. So guys, here, I think all of you understand this today class. I hope so. Okay.
Yes, sir.
Okay. So this is our today class now here. Let's meet on the next day class. Have a nice day, guys, all of you. Bye. Take care. Good day to all of you. Have a nice day.
Thank you, sir.
Yeah. Bye bye. Bye all of you. Bye Abhinav. Bye Sohail. Bye Vasant.